Hey, hi, good morning, one and all. T we are Today I'm here to discuss about the project which was made by me and one of my classmates, Sai, which was based on vision-based vehicle detection system in traffic surveillance systems. Nowadays, we can know that rising traffic congestion is an inescapable condition in large and growing metropolitan areas across the world. And to overcome this situation, traffic signals are very essential to guarantee safety road, especially at intersections. And this monitoring and controlling city traffic is becoming a major problem in many countries, in many cities. Uh, to overcome this situation, we propose this project based on image processing, OpenCV, HAR cascade algorithm, and many other tools. In this project, we can use the a long short-term model instead of HAR cascade algorithm. But there are so many drawbacks for the long short-term memory model. This is mainly due to the sequential computation in the LSTM layer. We can remember that LSTM requires sequential input to calculate the hidden layer weights iteratively. In other words, you must wait for the hidden state at time t-1 to calculate the hidden state at time t. And there are many drawbacks for the LSTMs. The main reason was it will take so much long time to train, and it takes more memory to train, and they are easy to overfit, and they are sensitive to different random weight initializations. So to overcome the situation, we used HAR cascade algorithm. In the coming slides, my friends, I will explain about those things. Now coming to the abstract, traffic analysis has been a problem that city planners were dealing over the years. First, as consider the road situation analysis for traffic control and ensuring safety of people. And this analysis of traffic may account for the number of vehicles in area for some time and the class of vehicles. If the vehicles were big, so that it will create a more traffic at the signals. So to overcome this situation, the vehicles are counted in each lane, and the time for the each lane is allocated. So to detect the images, we are using the image processing algorithms like detection algorithm and counting algorithm. And these vehicles are detected using HAR cascade classifier, and detected vehicles are counted. And in this project, we will give some video as the input, but in real time, we'll fix the cameras at the traffic signals, and it will record the each line, and based on the line, it will divide the video into different frames, and based on those counting, it will allocate the signal for each line, and based on the count of the vehicle, appropriate signal timing will be allocated for each line. And for this, we propose a system. The main goal of the proposed system is to improve the traffic control by adding the necessary additional features and new technologies into the application. As of now, they were using some electronic sensors and the infrared sensors at the traffic signals, but they are the optimization of those sensors was very less. So to overcome the situation, we proposed this system to control the traffic light by image processing. And for this model, we'll place the cameras alongside the traffic street poles to capture the image sources. It will capture the image sequences, and then image processing will process the image and changes the light based on the count of the vehicles. And it shows that it can decrease the traffic congestion and avoids the time that being wasted by the green light on an empty road. And here we will take some video as the input, and time for the each lane is calculated as number of vehicles in the line multiply by time assigned to each vehicle and base time. And the output will be time allocated to the particular line for the vehicles to move. And implementation. As we told, that video will be given as the input, which is further divided into the frames based on the frame detection. And we are using the image processing because it is a method to convert an image into digital form and perform some operations on it. In the coming slides, he will explain about those. In order to get an enhanced image or to extract some information, we give the image or video as the input in this project only. But in the real time, as we told, that we will fix the cameras, and it gives the image or associated characteristics with that image. And first of all, what is image processing? Image processing is a method to convert an image into digital form and perform some operations on it. In order to get an enhanced image or to extract some useful from it, there are two types of image processing. One is analog, and the other one is digital image processing. The analog image processing is applied on analog signals, and it processes only two-dimensional signals. And analog or visual techniques of image processing can be used for the hard copies like printouts and photographies and videos, etc. And a digital image is a picture that is stored on a computer. It has been digitalized, which means it has been changed into a sequence of numbers that computers can understand. And the digital processing techniques can help in the manipulation of the digital images by using computers. So from here, my friend Sai will explain about the code and how the output will be, and how it will detect the image. It will detect the images, and how it will count. It. Thank you.
Hi everyone, this is Sai. Next, I'm gonna explain main algorithm. This is air cascade algorithm. So we use this algorithm as the classifier because it gives the vehicle density count on the road. So it's an effective object detection approach, which was proposed by Paul Vela and Michael Jones in their research paper that was published in 2001. So mainly this classifier is used to detect the object in the video frame. So this algorithm is capable of differentiating vehicles from different objects. Like this air cascade is it's a machine learning based approach where a lot of positive and negative images are used to train the classifier. So basically, the positive image means the images that we want to find the information like people, vehicles. And negative image means images of everything else which do not contain the objects we want to detect. Coming to the OpenCV, it's an open source computer vision library. It's a machine learning software library. It has more than 2,500 optimized algorithms. In that we have algorithms like recognize faces, identify objects, classify human actions, track camera movements, etc. These algorithms we have in OpenCV. So mainly the system it includes a camera facing a lane that will record video of the road. So the video clipping sufficiently processed to know the traffic density. So according to this OpenCV, a control will send the command to the traffic LED timer to show particular time on the signal to manage traffic. So mainly the basic idea is to get count of vehicles in each lane, and we need to allocate the timing based on the count. So this architecture of the system. First, we need to give in a video as an input to the system. After that, by using the frame extract code, it will automatically extract the frame from the video. And next, we'll use the foreground detection. It is to remove the extra area. Next, image enhancement should be done because to remove the blurriness to increase the brightness of the image. For that, we need to do image enhancement. Next, image analysis should be done. After that, the vehicles are detected by using the vehicle detection code. So after the count of the after detection of the every vehicle, count will be increased. So based on the counting, the signal will be allocated. So these are the frames that are divided from a video. This is the vehicle detection pictures. Like the red rectangle box is detecting the vehicle. So this is the output. Like it shows four lanes. So now I will explain the code. So this is the code. This is the frame extract code that we are used to extract the frames from the video. And next, this is the vehicle detection code to detect the vehicles from the extracted frames. So these two codes are imported in this mythologic.py. So we don't need these two files. So coming to this, first we need to import everything like computer vision, time, numpy. So after that, uh, uh, we took a class signal light. In that we implemented different functions and declared sizes. These functions like set green, set red, etc. Next we took an array mylist. So by using Cascade classifier, we need to load the trained model car.xml. So next we have given the signal light red to the 3 lanes and green to the 1 lane, as one is red, 1 comma 0 1 comma 0 1 comma 0 are red and 0 comma 1 is green. So coming to the while loop, if the list having FES less than 500, then we need to read the images to the mylist 0 mylist of 1 has gone. So after that, we did image enhancement and image analysis and change the images to grayscale for extracting meaningful information. So next, using detect multi-scale, we will detect the vehicles from the frames. So next, initialize count equal to 0, and if founds a car, red rectangle will be displayed to the detect vehicle, and count will be increased, and this count is assigned to the mylist dot vehicle count. Same we have done for 4 different list of signal lights. Next, we need to manage the four signal lights and process the signal lights. So this is the code that we are managing the signal light for the 4 lanes. So this CV2 circle is used to assign the size for the signal, green, red, orange. Those are same for the 4 lanes. And this put.text is used to put the giving the timing for the signal. So after that, we have to arrange these 4 lanes as an horizontal stack using H stack. So now I will show the output of the program. So this is the output. First, one. Yeah, this is the output. First, the 4th lane it is going, and the remaining 3 lanes will be stopped. Like they are in red. So after that, next lane will be set to green. So after every it will automatically detect the vehicles and given the signal light as light like 4. So after that, it will automatically set the next lane and red to the previous lane. Yeah, thank you.